Carrying both rail and motor traffic, the bridge provides the means for delivering heavy equipment and construction materials to all parts of the project. It is a steel plate girder bridge with 9 150-foot spans. This bridge will also play an important role when the flow of the river is stopped and the water diverted through the outlet works. Closure of the dam will be accomplished by bringing trainloads of rock onto the bridge and dumping them over the downstream side. This rock dam will slow the river enough so that it can be diverted through the tunnels and around the dam, while the center section of the embankment is completed over the old riverbed. After the bridge has served its purpose, the superstructure will be removed and placed across the spillway channel. The piers will remain as part of the embankment. During the winter, earth moving is carried on only where the material is unsuited for use in the dam, as frozen earth cannot be compacted properly. One of the jobs successfully carried on during the winter was the drilling of the vertical ventilating shaft for the test tunnel. Located directly over the center line of the tunnel, it will provide fresh air and an emergency exit. The final 42-inch bore extending 100 feet below the existing surface is lined with steel casing. Tests made inside the shaft will determine any movement of earth in the proximity of the test tunnel. In constructing the test tunnel, a 7 by 9 foot access tunnel was first driven 200 feet into the hill, where it was enlarged to the full diameter of 36 feet. The access tunnel was constructed directly beneath a thick layer of lignite, thus reducing the size of timber supports required. The work of constructing the entire test tunnel was accomplished by blasting, followed by removal of the loose material and placing of the steel and timber supports. The full diameter section of the test tunnel will eventually become one of the 8 tunnels, which will be constructed to provide a means of releasing water from the reservoir and of generating hydroelectric power. This test tunnel was built to obtain data for the design of the concrete lining of all the tunnels, and to determine the best methods and most suitable materials to use in constructing them. This portion of the test tunnel has an outside diameter of 36 feet and will have a finished diameter of 29 feet when lined with concrete. Considerable timber and brush exists along the banks of the river and must be removed from the embankment and reservoir areas to prevent its rising to the surface and floating into the gates of the outlet works. The larger trees are cut into lengths, then sawed into rough lumber to be used for scaffolding and forms on the construction job.